Unix is the most important operating system in history. It's influenced almost everything in computing. Today we're going to talk about its origin story and why it's been so influential. Welcome to Kopek Explains Software, the podcast where we make computing intelligible.
This week, Dave, we're going to learn about Unix, a foundational operating system. I guess we should just start with what is Unix?
And there's really two ways we can talk about Unix. There was an actual product called Unix that came out of the 1970s, and then there's the whole philosophy of Unix and all of the other operating systems that have been built out of that philosophy and that standard. So when people talk about Unix, they sometimes are talking about the specific product, and we'll get into what that was. And they're also talking about all the newer products, newer operating systems that have come from that original product, in philosophy, in origin and history, and in also design.
So where do you want to start?
So why don't we start with the beginning, which is Bell Laboratories. Okay. Bell Laboratories is an arm, or was an arm. It still exists, but back then it was a research arm of AT&T. AT&T was the big phone company in the United States. There was a monopoly, controlled basically all long-distance calls in the United States. It was a government-imposed monopoly, in fact. And they had a research arm that looked into new systems for the telephone network, but also looked into computing applications. And they did a lot of really cutting-edge research, actually, at Bell Laboratories. And one of the things that they did research into was operating systems. And General Electric was working with some of the researchers there on a new operating system called Multics. And they were collaborating on that. And then they were thinking, you know what, some of the researchers there, maybe we should have something a little less complicated, a little more refined for some smaller mini computers that we have around the office. One of those was what's called a PDP-7, and a mini computer wasn't so mini by today's standards, but it was smaller in terms of both horsepower and also in terms of size than the large computers that Multics was made for, which were more mainframe type of computers. And so one particular individual, his name was Ken Thompson. He worked with another person named Dennis Ritchie at Bell Laboratories to create the first version of Unix for this PDP-7 computer, built out of some of the ideas that were coming from Multics. And we'll talk in a few minutes about some of the philosophies that went into Unix. But anyway, they developed this operating system around the year 1969, 1970, and it really got released into the wild a few years later, 1972, 1973, for other people to use outside of Bell Laboratories. But amazingly, the original version was really built in just a few weeks of these two kind of hacking on it. And a lot of other really well-known people in computing were at Bell Laboratories at the time, people like Brian Kernighan, and they had some hand in its evolution as well. But if there were just two people that we could talk about this whole story beginning with, it would be Ken Thompson and Dennis Ritchie.
And for our listeners who maybe haven't heard yet, they can go and listen to our What is an Operating System episode to really understand how important and integral operating systems are.
Yeah, that's actually one of our most popular episodes. It's episode 2 of the series, and I'll put a link to it in our show notes that people can go back and take a listen to it. Anyway, so they developed this operating system, Unix, and one thing that they did along with developing the operating system was develop a programming language to be used with the operating system that they would then actually port the operating system to, and that language was C. And C is still one of the most popular programming languages in the world, and C and Unix kind of go hand in hand. And so Unix and C are these like stalwarts, these old, ancestors of everything else that's come in computing the last 50 years. They've been incredibly influential.
Would you say that in creating and developing Unix and C that they were really creating a whole ecosystem?
Yeah, they were creating an ecosystem because they were creating both a way of creating new programs with C and with some of the tools and utilities that were built into Unix, and then also building a runtime environment for those programs by building the Unix operating system. So absolutely, they were creating a whole ecosystem, but I don't think even they knew how influential it would be. And as we'll see as we go through discussing its history, really almost every operating system today has been derived from Unix.
So what was the approach or the philosophy of Unix as it was being built?
So I think at first they were trying to take some of the ideas from Multics and make them smaller and simpler so that they could fit onto this PDP-7. But what happened over the next few years was there was some amazing innovation amongst not only the primary two people working on it, Ken Thompson and Dennis Ritchie, but a lot of the other people at Bell Laboratories who collaborated with them. And this over time amalgamated into what is known as the Unix philosophy. And it was actually defined by McIlroy in a paper called The Unix Time Sharing System that was published in 1978. And I'm just going to tell you 4 points from that philosophy that he defines. These are mostly his words. I'm just paraphrasing them. But let me tell you what these 4 points are. The first part of the philosophy, make each program do one thing well. To do a new job, build afresh rather than complicate old programs by adding new features. So we have slim programs. We have small programs that just know how to do a single task. And instead of going and trying to add a new feature to an existing program, we go and create a new program. So that was the first part of the philosophy. The second part, expect the output of every program to become the input to another as yet unknown program. Don't clutter output with extraneous information. Avoid stringently columnar or binary input formats. Don't insist on interactive input. In other words, we should be able to take two programs and put them together. The output of one program can become the input for another. Therefore, we can merge the streams, if you will, of one program and another program together to get a whole new combination that does something sophisticated for us. So we're taking simple pieces and putting them together to make more complex wholes instead of making custom interfaces for each individual program and then adding tons of features to it, which goes back to the first point. Next point. Design and build software, even operating systems, to be tried early, ideally within weeks. Don't hesitate to throw away the clumsy parts and rebuild them. Now, there's a saying today in kind of the startup world and software development and also in business called fail fast. And I think that really summarizes this third point. The idea is you want to right away try some ideas out, test them out, see how they do, and then be ready to throw them out and so that you don't get stuck with them. Don't go build like a huge cathedral and then find out that you built it all on a foundation of sand and it's all going to collapse. So you want to try things out early, get things experimented with, kind of use almost like a bit of a scientific method. You think this is going to work well, you try it out, see how it's going, then you adjust your expectations, make a little change, try something else out and see how that works out. Last point. Use tools in preference to unskilled help to lighten a programming task, even if you have to detour to build the tools and expect to throw some of them out after you've finished using them. So you'd want to build tools. We're not saying that just because you're building simple programs, they're not useful programs. You want to build tools that allow people to do interesting things. You don't want to go and build just like one-off things that you won't be able to use again. So if you take all four of these points together, it's all about making small programs that work together to do more sophisticated wholes. But you want to make useful, interesting small programs, but they have to have a very defined function and not go out of their sphere of what they're good at.
So that's the philosophy for both building Unix and then also the ecosystem that was created from it. And that has trickled down into the legacy of Unix, into these other operating systems that are using that system. How did Unix go from being something within Bell Laboratories to being distributed widely and becoming this ancestor?
So they did try selling it at first, and they would license Unix out for about $20,000 a license, which was even a lot more money back in the 1970s. But an interesting thing happened, which is when they licensed the software, they also distributed the source code to the software to some of the licensees. And some of the licensees went and actually built on top of that source code. And one of those was actually the University of California at Berkeley, where they developed the Berkeley software distribution, also known as BSD, which was an extension of Unix, modified some of its features. The lead programmer on that project was Bill Joy, who would later go on to found the very influential Silicon Valley company Sun Microsystems. But anyway, the Berkeley software distribution, you could think about as kind of like a fork of Unix. It was like another version of Unix. And because it was developed out in the open, and they would actually distribute all their source code, the BSD folks, it actually led to even further versions being developed. But also people were just seeing, this is a pretty cool tool, Unix, and all of the programs that come with it and how they can be composed together. And it started to influence the design of other operating systems. But not only that, it led to a lot of people cloning it. So every big tech company, every big software company seemed to be coming out with their own version of Unix. I just mentioned Sun Microsystems. In the early 80s, they launched workstations based on a version of Unix called Sun OS. Later on, it would be called Solaris. Microsoft even released a version of Unix called Xenix. But every big company, whether we're talking about DEC, or we're talking about Compaq, or we're talking about HP, or we're talking about even Apple, they all were coming out with their own versions of Unix. And this was happening throughout the 1980s and throughout the 1990s. So we sort of have an evolution from Unix being an AT&T thing in the 1970s to BSD coming out around 1980 to all these different proprietary clones of Unix, some of them using licensed code from AT&T, some of them not, in the 1980s and the 1990s. And so this led to what was called the Unix Wars, which was where there were all these different proprietary clones and forks of Unix, and there were some free software ones as well. Richard Stallman starts the GNU project in the 1980s, and we talked about that in a different episode on open source software, and we also talked about that in our What is Linux episode. I'll put links to both of those in the show notes. But it led to this competition amongst all these different versions of Unix wanting to get some market share. Now, these were mostly operating systems for servers. So they were mostly being used on mainframes, on mini computers in the 80s and 90s. And then it was trickling down into the workstation market, which were kind of like high-end desktop computers. Desktop computers more powerful than personal computers, but not necessarily as powerful as servers. So they were kind of an in-between used by a lot of scientists and engineers. But this workstation market became kind of the center of the Unix wars. And it was where all these proprietary distributions were kind of competing with each other. And there's some famous companies that were involved in this, including Next, which would later on be bought by Apple and turn into Mac OS X and iOS. And Sun Microsystems, which was certainly one of the most influential Silicon Valley companies in the 1980s and 1990s. So people were competing with mindshare with these different versions of Unix, but the issue was they were not necessarily all compatible with one another.
Were all of these different clones following the philosophy that we talked about earlier?
Yeah, they were basically all following the philosophy that we talked about earlier. And for the most part, you could take your skill set from one and use it on another. They were similar enough, and there were many of them. There were probably a dozen different proprietary Unix clones that were out in the 80s and the 90s that were pretty widely used. So you could take your skill set, but they weren't necessarily binary compatible. They weren't even necessarily source compatible. So your program that you wrote for one, you would have to make some tweaks to it to get it to run on another. Mm-hmm. And you couldn't usually just take a program that had already been compiled for one and just run it on another. So they weren't generally compatible with each other beyond that a user who knew how to use one would be comfortable using another. And they would all follow the same sort of philosophy.
So did Unix start to standardize? Is that still the case where you can't move between these different clones?
So they did come out with a standard eventually, and that standard is called POSIX, P-O-S-I-X. And that standard specifies certain ways of laying out the operating system, certain libraries that should be available to developers, and therefore making all the operating systems that adopt it somewhat source compatible. So you could take a program that was compiled for one and just go and recompile it for another. And so this standardization process is happening in the early 1990s. But another big thing that's happening is that Linux comes out. And Linux is another of these operating systems that's kind of a clone of Unix. And we talk about where it came from and the specifics of its origin story, because it actually came from another operating system called Minix in our episode, What is Linux? And I'll put a link to that in the show notes. But Linux comes to kind of dominate the Unix world. Over time, Linux is a free operating system, both in terms of price and also in terms of freedom. It comes to take not only the mind share, but also the market share from all of these proprietary Unixes. People kind of put their development efforts into Linux, and Linux over time becomes better and better and better to the point where it's as good, if not better, than most of the proprietary Unixes. So people are like, why am I paying for this proprietary hardware? Why am I paying for this proprietary software when I could just buy generic hardware and use Linux on it? Mm-hmm. And so over time, Linux kind of takes all the air out of the room from the Unix wars, and it's still following that Unix philosophy, But now you don't have to have all these different incompatible versions, and you don't really have to pay for it. You still pay for
Sounds pretty
support.
good.
Yeah, there's still distributions of Linux, of course, and people still do pay for Linux in a sense. But it's a collaborative effort where all these different companies that used to be competing with one another are all working together. I'll give you some examples. So HP had their own proprietary version of Unix. They still do, actually. IBM had their own proprietary version of Unix. They actually still do as well. They both have invested a ton of money into Linux. So they actually pay some of the people who work at IBM, who work at Hewlett-Packard, no longer called Hewlett-Packard, to work on Linux. So there's people working full-time at these former Unix war companies to make Linux better. So the industry's kind of just all gotten behind this one effort instead of having this like split up effort. And they kind of had to do that because what was happening in the 1990s and early 00s was that Microsoft Windows was actually becoming a contender on the server side with Windows NT. And so by being so distributed and kind of not having their efforts united, all the different Unix vendors were starting to really get hurt by Windows NT and the rise of Windows on the server side. And so Linux has been the counterbalance to that. And in fact, Linux is really the dominant server operating system by a wide margin versus Windows today. And I'm not sure if they'd stayed distributing all their efforts amongst all their different operating systems, if they would have been able to put up quite the same sort of front against the threat from Windows NT and then later on Windows 2000 and modern Windows servers. So they got behind it. Yes, it was more economical for them, but I think it also made strategic business sense as well.
Did Unix stay a part of Bell for a long time, or when did it separate from that?
Yeah, so Unix kept coming out in new official quote-unquote versions from Bell Laboratories all the way up to, I believe, the early 1990s. But nobody was really using the official AT&T versions of Unix. People were using all these different Unix War clones of Unix. And some of them were based on licensed source code from AT&T. But one of the most interesting stories is what happened at BSD. That was that version of Unix that was being developed at the University of California at Berkeley. And it actually evolved into some totally free versions of Unix, versions that no longer had any AT&T source code. And there were actually legal fights about this. Did they still have AT&T source code? Because then they could be in legal trouble with AT&T. But yeah, they actually evolved to the point of being completely free by the early 1990s. And they turned into 3 operating systems that are still with us today: NetBSD, OpenBSD, and FreeBSD. And so these are actually in many ways competitors to Linux. So just like Linux, they're free both in terms of cost and in terms of freedom. And they offer most of the same facilities as Linux, but for various reasons that are beyond the scope of our show today, they didn't get as much support from the industry, and they didn't get as much backing to really become, at the same level as Linux is today. But yeah, they still exist, and they can trace their history all the way back to the original AT&T Unix. And so can a lot of operating systems. In fact, I mentioned this a little bit earlier, but modern iOS and modern macOS are built out of what was originally NextStep, which was built out of, and they still continue to add parts from, FreeBSD. And so they actually also can trace their roots all the way back to the original AT&T Unix in a sense. And if you think about Android actually runs on the Linux kernel. So Linux can trace its ideas and philosophy back to Unix, and then Linux is used in Android. So if you think about it today, basically every major operating system except for Microsoft Windows that we use today is somehow evolved from or based on the philosophy of Unix. Now, Microsoft Windows has been influenced by it too. So it's not like Microsoft Windows is outside of this whole thing. It's just not directly a descendant of the original Unix or the original Unix philosophy. But certainly it's been influenced by some of the ideas that came there, including the C programming language, which is used across basically all systems programming, no matter where you're working. And C came out of Unix. So Unix had such a big impact, and that philosophy we talked about earlier, it's such a big impact, you really can't understate it.
Where do you see these Unix systems developing towards? Like, how are they changing or growing, or what do you think might happen in the future with them?
Well, I think one of the big discussions right now amongst people in operating systems is, have we actually been too influenced by Unix? If you think about it, it's been around now for 50 years. Basically, every operating system, like I said, except for Windows, is some kind of derivative or clone of it at some level. And maybe there's not been enough innovation in the sense that we've all been thinking in this one paradigm. What ideas have been crowded out because Unix is so popular? And there's been people who've written entire books about this that I've briefly read before. I'm not sure how exciting they are. But there have been other operating systems that were not Unix clones that never really made it, that came out in the 1990s and came out in the 00s. And we don't know what that other world would look like. What would a world where every operating system isn't basically POSIX compliant look like? What would a world where basically every operating system wasn't built with C look like? I don't think we really know. We see kind of, hobbyist operating systems. We see commercial efforts that don't go very far that have gone that direction, but we haven't really seen something that's totally different from either the Unix line or from Microsoft Windows that has actually made it to a mass scale of popularity. And so I think that that's really the big question. It's not so much what did Unix do wrong? And there are people who feel Unix has done several things wrong, but it's more like just what other ideas got crowded out by it, I think, that is more of a concern. And so this is an area, we often think about operating systems as kind of like a solved problem in some ways because we have ones that work good enough. But I think this is an area that could be very interesting for future computer science research is how can we build operating systems in a totally different direction? And has Unix, what if we throw out everything we think about operating systems that's so highly influenced by Unix and really start over? And, it's much easier to tear things down than it is to build them up. So that's a big ask. But I think that maybe, 50 years is a really long time in computing. Maybe we are too much in this Unix mindset. And maybe there are new ideas out there that have yet to be explored that have been crowded out. All right. Well, thanks for listening to us this week for a more technical episode. And I want to remind everybody to subscribe. So whether you're listening in Spotify and you hit that follow button, or you're in Apple Podcasts and you hit subscribe, that makes sure you'll hear about our future episodes. Sometimes we do an episode that's more technical, and sometimes we do an episode that's just on a popular software application and its history. So hopefully there's something for everybody. And Rebecca, how can people get in touch with us on Twitter?
We're at Kopec Explains, KOPECEXPLAINS.
And we'll see you next week. Have a great week.
Thanks for listening.